So let's try to understand how electrolysis works. So this is an electrolytic cell, and the goal for this is to force a metal to take electrons even though it does not want it. So you've seen in the videos that you can take a piece of solid nickel and you can have some copper plus 2 in the solution, force electrons to go onto copper so that it becomes copper solid as it gets plated on the outside of the nickel. And now the nickel looks a little bit orange because the copper solid is plated on the outside of it. So copper plus 2 doesn't normally want the electrons, but you can force it. And the way you do that is using electrolysis. Electrolysis uses a battery to force the electrons to go somewhere where it doesn't want. Okay, so here's an example. So here we have Cl minus, and Cl minus wants its electrons. It doesn't want to get rid of it. But you're going to take a battery, the positive side of the battery, to pull electrons away from the Cl minus. So in the beginning, you have Cl minus. It's going to become Cl2 as it gives away 2 electrons. Okay, so electrons are coming out of solution here, going through the wire. The battery is used to suck up all the electrons from the Cl minus. Now the electron is being pushed this way even though it doesn't want to. Okay, so which means that this is now the negative source because its electrons are coming from here, going to this metal. And because it's attached to a negative, this is also going to be a negative electrode. It's a little bit confusing, but that's how they name those electrodes. Okay, or they put the charges. Since this is attached to the positive side of the battery, this is also the positive electrode. Okay, so the electrode comes in and they see sodium plus. Okay, sodium plus does not want the electron at all. Okay, but it's going to be forced to take that electron. Okay, and it's going to become sodium with a 0 charge. In this case, it's going to be molten sodium, which is a liquid. Okay, so this is the electrolytic cell. Again, the positive side of the battery will pull electrons away from the Cl minus, as the negative charge of the battery will shove electrons to the Na plus and become Na0. This is the same way they do this. They're going to shove the electrons this way, so the copper plus 2 takes the electron and gets plated on the outside of the nickel. Okay, so let's label our electrodes really quickly. What's happening to Cl minus? Cl minus is being oxidized. That's correct. Okay, because it's more positive. It's negative here, it's 0 here. And so this is the anode. Electrons are still going from the anode to the cathode. So this must be the cathode. And the cathode is where reduction takes place. Okay? So this is your electrolytic cell. So let's go ahead and look at your cell potential. So here we have 2Cl minus becoming Cl2 plus 2 electrons. And I'm going to look at the electrochemical, I'm going to just write the other one too. Na plus electrons is going to be Na liquid in this case. It doesn't matter if it's liquid or solid, but it just happens to be liquid here. So this is going to be a 2, and a 2 to balance the 2 electrons. Now looking at the cell reduction potentials for Cl minus. Cl minus here, Cl2 taking in the electron. It wants to take the electron, but you're doing the opposite way. So it's going to be positive 1.359 is the reduction potential. Voltage, and you know that's going to have a negative in front of it for the formula, okay, because it's been flipped. So Na, you're shoving an electron to it. Do you think it's going to be positive or negative for that potential to put electron onto sodium? Okay, I don't think sodium will want the electron, therefore it should be negative. So let me look at that reduction of sodium. Yeah, negative 2.71, that's huge. Therefore, you really need a strong battery to put electrons to Na+, so negative 2.71. Okay, so now this is the oxidation, which is the anode. This is the reduction, which is the cathode. E cell is equal to E cat minus En is equal to, the cathode is negative 2.71 voltage minus, that's going to be the minus that's put in front here, plus 1.359 voltage. Okay, so that cell potential is going to be a negative 4.07 volts, which means this is quite non-spontaneous. Therefore, it will not happen on its own. You will need a battery to make this happen. Okay, and that's why we use a power source here. Okay, and that is an electrolytic cell.